Okay, welcome to our lesson on zero exponents. Um, so I guess before we do zero exponents, you should just recall basically what an exponent is. If the exponent is a positive integer, so something like 2 to the power of 3. So you should know what that means, right? All that means is 2 times itself 3 times. So 2 times 2 times 2, which is equal to 8. But then the question becomes, like, it's easy to do any positive number, right? It's just multiplied by itself, whatever the exponent is times. But what about something like 2 to the power of 0? What does that equal? So what does that mean? It's saying 2 times itself 0 many times. And a lot of people will guess that this is equal to 0, but that's not the case. 2 to the power of 0 is not equal to 0. And I think the reason they guess it is they think, okay, I'm multiplying by 0, but that's not what you're doing. This says 2 times itself 0 many times. So you're not multiplying by 0. It's actually pretty easy to figure out what this has to be based on our division law. So our division exponent law. So recall this rule from exponents, that if you have x to the power of n over x, over x to the power of, let's say, m, then you can just subtract the exponents. So x to the power of n minus m. So for example, if you had something like 2 to the power of 5 over 2 to the power of 3, you can simplify that to 2 to the power of 5 minus 3, or 2 to the power of 2, which is 4. So if you remember this rule, then that's basically going to tell us what we have to make this equal to. So just consider this simple example where, let's say you're doing 2 to the power of 5 over 2 to the power of 5. Well, there's two ways we could do this. We could apply this division law, that's equal to 2, that's equal to 2 to the power of 5 minus 5, so just by subtracting exponents. So 2 to the power of 0. So it's 2 to the power of 0, but what if you didn't do the exponent laws? So just by expanding, by doing the exponents rather than applying the exponent law. So just by evaluating without the exponent law. 2 to the power of 5 means, so let's just rewrite it, 2 to the power of 5 over 2 to the power of 5. Well, 2 to the power of 5 is 32 over 32, which is equal to 1. Well, these are the same thing, so this thing here better be equal to this thing. So therefore, 2 to the power of 0 is equal to 1. And that's true for any base, not just 2. Right? In general, and we'll say x to the power of 0 is equal to 1 if x is any real number. So that's basically any possible decimal number, fraction, anything. With one exception, x cannot be equal to 0. So what does that mean? That just means anything to the power of 0. 1 million, what was that? That's 100,000. To the power of 0 is equal to 1. 2 over 5 to the power of 0 is equal to 1. Negative 3.8 to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. Okay, so that's all you need to know about zero exponents. The one exception I made here was that x cannot be equal to 0. Sorry, ran out of space there. So you should just be aware of this. 0 to the power of 0 is meaningless. Or you might also say it's undefined. So, for example, like try punching in your calculator if you have a calculator nearby. It'll probably give you an error. That's because this does not equal 1. This doesn't equal anything. It doesn't, it's not a proper mathematical expression. You can't write this. It just doesn't work. Um, and if you want to sort of look at an explanation, if you remember how we got this rule by using the exponent law, well, if you said 0 to the power of 5 over 0 to the power of 5, well, that doesn't make any sense because 0 to the power of 5 is equal to 0 over 0, which is undefined. So we can't use the division, you can't use that, or, by exponent laws. 0 equals 5 minus 5, 0 to the power of 0. So similarly, just like this is undefined, this is undefined. Although technically even doing this would be wrong because it was meaningless to begin with. So that's all you need to know about zero exponents.